Okay, this is a Thermosiphon Arrestor valve. It's used to control the temperature in the tank through solar optimization. This measures the temperature from the flow of the collector back into the tank, and it's a little bit different to the open circuit model. This particular product is only used on our closed circuit system. It has different settings, it's got different characteristics about how it should be connected, and it shouldn't be used ever in an open circuit model. So just to point this out a little bit clearer to you, you'll see these arrows on the body of the valve and the words tank there, and that is the direction that the flow from the collector to the tank is being connected at all times. Please ensure you do not put it the other way around. In an open circuit environment, there is a different valve, different temperature settings, and is connected in a different manner than this valve. So this is only to be used in the closed circuit system. You'll only get it when you order one of our closed circuit systems. It will always be in the parts kit amongst all the other components that we put in there ready for connection with this. These fittings have to be connected on the job. Make sure you glue them up or seal them up or tape them up to satisfactory sealment requirements and compression tightness. This goes onto the tank, connecting it to the hot pipe. Now the hot pipe we provide you has an extra 50 mil of copper either side. So this allows you to move the tank around a little bit or the collector down a little bit. So you've got a little bit of play, and just with the copper cutters you can then cut the pipe to desired length. But please ensure that you remember you've got to do that, and you've got to measure it on site. So once you've done it, it's fixed and it's in place. All right, as I mentioned before, we have two types of Thermosiphon Arrestor valves. This one is for the open circuit model, and as opposed to the closed circuit Thermosiphon Arrestor valve, which we mount or connect into the hot return from the collector, we put this one in the cold flow to the collector. And you can see that the arrow, that is the flow direction. Unlike the other one, which is arrows pointing to the tank, we want this one pointing away. It's also evident inside it that there's a sensor probe which measures the temperature in the tank. And what we're doing is, in effect, closing the flow to the collector off, but we're allowing potable water still to come into the tank and into the main tank to allow it to go out. So this is different. It's a different set temperature, and it allows for it to operate because of the open circuit nature of the collector. It sets at a little bit lower temperature and maintains the temperature at our desired operating conditions all the time. So just please make sure about that. You'll always see the arrow away from the tank, and this is on an open circuit tank. This tank here is still our closed circuit system. I'm just showing for an example, so if you come across this in the field, you'll know the difference between the two.